First question, ethyl acetate reacts with CH3MgBr, that is methyl magnesium bromide. It's a Grignard reagent to form what? Secondary alcohol, tertiary alcohol, primary alcohol and acid, or an acid. Okay, so first of all we need to know what is an ethyl acetate. That is CH3C double bond O. This is an acetate group attached with ethyl branch, that is C2H5, and when it is react with CH3MgBr, it first forms an intermediate where this C double bond O bonds breaks and this MgBr gets attached over here on this carbon oxygen bond. Mg plus and this carbon negative sign, whereas this carbonyl group oxygen have negative polarity and the carbon have positive polarity. So this magnesium will attach over to the oxygen and this CH3 will attach over to this carbon. So we are going to get an intermediate like the terminal CH3 as it is. This CO attached with MgBr and here it attached with CH3. Then here we have oxygen and C2H5 bond as it is. Now when you treat it with water, okay, that is the hydrolysis. So when you treat it with water, acid hydrolysis, this OMgBr will going to break down. Okay, now this is positive, this is negative. H2O may we have H plus and OH minus. So this minus and MgBr will going to make a byproduct and this H will going to attach over to this oxygen, making OH group. But now during this hydrolysis, we have this ether linkage. So that will also undergo hydrolysis during this process and H get attached over here with the oxygen and OH get attached with the C2H5. So let's see how the product looks like. So this CH3, this C and this CH3 will remain as it is. This O will become OH and this bond will also become OH. So now here we have two OH group. So now this 2H group on a single carbon is unstable. So this will undergo dehydration, that is the removal of water molecule, and it will going to form CH3 C double bond O CH3, that is a ketone or a carbonyl group again. But now if this molecule again further treats with the Grignard reagent, that is CH3MgBr, so carbon positive, oxygen negative, and this Mg positive, carbon negative. Again the similar pattern, this CH3 will attach over here to this positive carbon of carbonyl group and this Mg positive will attach over to this negative polarity oxygen of the carbonyl group. Now what will be the expected intermediate product? We get CH3, C, here you're going to get O MgBr, then this CH3 as it is, and now this CH3 will come here. Then again if we do the hydrolysis, that is acid hydrolysis, so just the similar step we did here will going to take place and you're going to get replace this MgBr with this H plus. So you're going to get CH3 C CH3 and this CH3 as it is, and now this O become OH. So the correct answer, or this, if you look at the structure carefully, it's nothing but a tertiary alcohol. So the ethyl acetate with excess amount of Grignard reagent will going to give you tertiary alcohol. This is tert butanol. So the correct answer among the given option is tertiary alcohol, option B. Looking towards the next question, identify the correct order of boiling points of the following compound. So first if you look here, it's an alcohol. This compound is an aldehyde and this compound is carboxylic acid. So now this COOH group and this OH group of an alcohol form the hydrogen bond in water or with each other, by which they have high boiling point. COH group shows strong hydrogen bonding, so it forms dimer also and have more boiling point than that of OH group. So now how we'll do the arrangement, that if the carboxylic acid is showing the higher boiling point, so it is 3 higher. Then I told it's an alcohol which also make the hydrogen bonding, so it's 1. And then the last, that's an aldehyde molecule which does not make any additional intramolecular forces, so that's 2. So correct answer among the given option that starts from 3 or the highest value 3 is in option B and D. We need second as 1. So it's there only in option B and then 2. So correct answer or the correct order of boiling point is option B. Looking towards the next question. Salicylic acid is prepared from phenol by. So the name reaction we are supposed to choose, whether it is Reimer-Tiemann reaction, Kolb's reaction, Kolb's electrolysis reaction. Okay, so let's do this reaction. Salicylic acid from phenol. So first we need to know the phenol. Phenol, when reacts with carbon tetrachloride in the presence of a base NaOH. So there's a removal of this H and one Cl from this molecule forming HCl, and the bond forms in such a way this OH and the H from this carbon will remove with the Cl forming HCl, and this carbon Cl3 remains. Now the further we'll react in the presence of base, so it will going to replace this chlorines with this hydroxyl group. So now we are going to get an intermediate which is highly unstable, that is this OH as it is. This carbon with 3Cl replaced by 3OH group. Now we know if the carbon have 2 OH group, we remove H2O from it and make a carbon in double bond. So let's make this, and that will remove water, that is dehydration. So we are going to get this benzene ring OH as it is, this carbon with one carbonyl group, and now this OH remains as it is, so we'll write it as it is. Okay, but this hydrolysis takes place in the presence of NaOH, so we don't get this as a product, we get the sodium salt first, and then we are supposed to do the hydrolysis in the last step, acid hydrolysis, so that this Na plus is replaced by H plus, and you're going to get the salicylic acid. That is this phenol with COOH. And this conversion of phenol to salicylic acid is called as Reimer-Tiemann reaction. So among the given option, the correct answer is option A. Looking towards the next question, which of the following is the strongest acid? So since we know that electronegativity of an element, that is the tendency of an atom to remove electron or to attract electron towards itself, is called as electronegativity. Okay, and we know that electronegativity or electronegative group strength is directly proportional to the acidity. Now if we look at the options, this is acetic acid, this is bromine substituted acetic acid, chlorine substituted acetic acid, and fluorine substituted acetic acid. Now we know among this is hydrogen, so we'll not count this for the strongest acid. We'll look for this halogens. So among the halogens, fluorine is having the highest electronegativity, then that of chlorine, then that of bromine, and the least is for this compound, that is hydrogen. So the acidity also goes in a similar way, that this molecule will have the highest the strongest acidity, then this chlorine, then bromine. So correct answer among the given option is option D. Looking towards the next question, which one of the following orders of acid strength is correct? So now we know that the carboxylic acid is the strongest acid, and we can see the carboxylic acid in all our options. Okay, so now we are supposed to look for the other one, that's whether it's an alcohol, water, or alkyne. So we know that water have acidity. Okay, so we have then less than that of a carboxylic acid, the acid strength is for water. So water is there in two molecules or two options. Then we know it's an alcohol, and the least acidic is an alkyne carbon, because hydrocarbons have very less acidity. Hydrocarbons with a double bonds, not at a functional group. So correct answer among the given option is option C.